Hello everyone and welcome back to another video. In this video we will discuss the applications of machine learning in 5G networks and roughly saying beyond 5G networks, or also called B5G networks. This will not be a very detailed discussion about each and every algorithm, its statistics, its mathematical working, modeling and everything like that. It will just be an overview of how machine learning, or particularly machine learning algorithms, are applied or are being applied in 5G networks, which are indirectly or directly being developed all over the world in today. As we know that networks are now shifting from 4G to 5G, therefore machine learning can have various applications in 5G and beyond 5G. Let us dive deep. Let's see what we will be discussing in this presentation. We will discuss a little bit of 5G, not very deep. Our main focus will be introduction to machine learning. What is machine learning and how and why is it applied particularly in 5G networks? We will look at an overview of algorithms that can be used in 5G. Similarly, we will study some particular case studies, for example machine learning and resource management, networking, mobility, how ML algorithms are particularly applied in these respective fields so that they can be modeled in a physical way or in a statistical way. And in the last two topics we will discuss a little bit in detail how the algorithms are particularly applied in intelligent authentication and similarly SDN in 5G, which is becoming very popular in network layer. First and foremost, let us discuss a little bit of 5G. What is 5G and how it is being deployed all over the world, some of its important features, and then we'll dive deep into machine learning algorithms. A little bit of 5G. Let us discuss some few important points of 5G. Although there are a number of important points, let us discuss a few. First of all, 5G is being deployed all over the world due to its increased generation. It is a successor of 4G. Obviously it has to provide some new functionality that 4G cannot provide. First of all, it is based on OFDM. OFDM is basically a method in which the signals are transmitted from one point to another. It can be understood really clearly from the net. This is not our topic here. OFDM basically stands for orthogonal frequency division multiplexing. It is kind of a technique in which devices can connect with each other via electrical signals. 5G increases the bandwidth, which means we can ultimately increase the number of devices connected to a particular base station, to a particular tower. Network slicing. We can divide by in 5G we have more bandwidth, which means that we can more divide the network into slicing. The more slicing, the more capacity, and ultimately the more number of devices we can support in 5G. Lower latency, we have lower number of losses. As technology advances, models are being more accurate, models are being more predicted, and therefore it is producing lower latency in 5G. Before going deep into each and every particular algorithm, it will be very beneficial to discuss about the algorithms of machine learning, or in particularly we will see what machine learning is basically is, how many portions is it divided in, and what do each particular portions or type specifically do. Let's see a very short discussion about it. To understand machine learning at a basic level, let us just loosely define what actually machine learning is. Machine learning is actually the training of a machine, or specifically speaking, it is the training of a machine in a particular program to perform a particular task in a specific way. What it means basically is that we have a task which we want to perform by the machine, so we instruct the machine to do the task in this specific way. The task could be anything. This is just a rough definition of what machine learning actually is. Machine learning is very more complex than this definition. Just understanding the basics of machine learning is basically divided into three types. First, supervised, unsupervised, and reinforcement learning. Let us first understand each and every type, their purpose, and some of the algorithms that are used in those types. Speaking of supervised learning is a method in which we provide the machine a labeled data set. Or in other words, we can say that we provide the machine with a given data set on which it is trained to perform future tasks. Examples of such of these supervised algorithms are SVM, also known as support vector machines, and KNN. It is also a very popular algorithm in supervised machine learning. Coming up to the next, unsupervised machine learning, one can guess that it's the opposite of supervised machine learning. In unsupervised machine learning, we do not provide a labeled data set to the machine. It is provided unlabeled data set, and then it produces results based on that. Examples of such are k-means algorithm or PCA. We will discuss these algorithms in a bit more detail in the upcoming slides. Roughly speaking, k-means algorithm is an algorithm in which data is clustered in a number of sets. How many number of sets? That all depends upon the user on how many sets he wants to create. The last, reinforcement learning. This is a relatively complex algorithm as compared to supervised and unsupervised. In reinforcement learning, we train the machine using some trial and error processes. What we basically do is that we train the machine to perform a specific task. Let's say that the machine performed a specific task correct way. Then there will be a feedback in the machine itself to tell the machine that it performed this specific task the correct way. In this way, the machine learns by new methods on which process is correct and which isn't. This is what we call trial and error. When machine performs a specific task, let's say in a wrong way, then the feedback provided to the machine is such that it gets to know that the process is done in the wrong way. This is all the explanation of what I want to say about trial and error processes. As I said before, this is a bit more complicated as compared to supervised and unsupervised. It's a bit more harsh to implement in real life. Examples: deep reinforcement learning and Q-learning. As we basically define machine learning, its types and some of the algorithm, it is now appropriate to discuss a little bit more about the algorithms, and specifically speaking, the applications of those algorithms in 5G. First, supervised machine learning. As we discussed before, supervised machine learning is a machine learning type in which the machine is provided a labeled dataset. Now for this, let us discuss a very few scenarios. We have applications, their key features, and the respective algorithms. In algorithms, let us just say, for instance, we have regression models, k nearest neighbors, KNNs, support vector machine, SVM. In case of regression model is something that distinguishes the data based on a function. We have a function and we have some data. We pass the data through the function, and depending upon the function output, our data can be classified in particular classes. This is what regression model basically does. Its application, we can apply it in channel and power distribution. We won't go specifically in each and every application as it will be very much complex, but it can be understood and one can satisfy on his own. K nearest neighbors. As we discussed before, it is a form in which clusters of data are performed. We have some data, we pass it to the KNN algorithm. The KNN algorithm in turn returns our data in a clustered form. Again, the clusters are numbered as the user require, and its application is in energy learning. We can learn about the energy distribution among the different nodes, among the different networks that are contributing in the 5G network overall. Support vector machine, this is also a very important. Support vector machine is some in which roughly speaking we can increase the limits of a data function. Now this is a bit confusing. Support vector machine is actually, we can say that it's a type of regression model, but I want to differentiate it here. Regression model is actually fixed. It's a fixed function. The data is passed through it and we get the output. Support vector machine kind of takes it to the another level. Support vector machine also has a function. Data is passed through the function and we get the output, but instead we also increase some ambiguities in the function. We increase the limitations of the function somehow, that the nearby data points are also included in the overall data set. This is what support vector machines actually do, and this is applied in handover solution. Handover solution is a very critical problem, not even in 5G but overall in wireless communication system. Handover solution is a very important and a critical feature that needs to be resolved and minimized in every possible way. Unsupervised machine learning, as we discussed before, is a type in which we do not provide a labeled data set. We will continue to proceed the previous structure. We have algorithms, their key features and their applications. We will discuss here PCA, ICA and K means clustering. We will see what are the key features and applications. Principal component analysis is something in which we define relations among data, and this relation is not specifically anything. We are basically looking for patterns among the data. This is just a rough speaking. This is not exact the definition of PCA. In PCA we are roughly looking for any pattern, for any relations among data that exist within them. PCA can be applied to smart grid. Now independent component analysis is something similar to PCA, but instead we are looking for some variance or correlation among the data. Again, loosely speaking, we are looking for some relation among the data. We can apply ICA into cognitive ratio analysis. K means clustering is a form in which data is organized into clusters, and it can be used in heterogeneous networks, those networks in which there's a lot of traffic, there's a lot of congestion going on, and there's a lot of delays and setups and all those delays. Reinforcement machine learning is something in which the trial and error process occurs. First of all, we have Markov decision process. In Markov decision process, the machine learns from the previous mistakes. A dataset is provided. The machine learns whether the dataset is performed correctly or not. Markov decision process can be applied to energy and power distribution in order to study a pattern, in order to study a distribution among the data points that preserve the energy conservation. A similar concept is called Q-learning. Q-learning is a method in which the best action is determined in a particular scenario. As all of these are types of reinforcement machine learning, these will work on the basic same principle, that is to perform trial and error process on the data. A concept similar to Q-learning is called as multi-arm bandits, in which some rough value is provided to the data and output results are determined based on that data. The machine similarly learns from trial and error, and this can be used to check the device connectivity. This can be used so that the devices are verified to be connected to each other, no data is lost, no nodes are lost, and 5G has a smooth connectivity. Let's talk about a specific case in which machine learning algorithms can be applied to resource management, which is in overall a single problem which frequently occurs in 5G. We will see how and which algorithms are applied to resource management in the context of 5G. Resource management, as the name suggests, is a type of management in which resources are organized with each other to minimize the resources. Two of the main resource management is power control and cache control. The name suggests that power control is something in which the powers of each individual node is controlled, and cache control is something in which the cache of the data among each individual node is controlled. In power control, we will first discuss about the usable algorithms. In power control, we have first and foremost SVM, Q-learning, and we have convolutional neural networks. All of these can be applied in order to determine the power control among different nodes. In the cache control, we have somewhat unsupervised machine learning and reinforcement learning. We can apply deep reinforcement machine learning, recurrent neural networks, and transfer learning. These are all comparatively new types of reinforcement machine learning that have been developed, but still these can be applied to these two particular controls in resource management. Next, we have machine learning algorithms in networking. We can see how the algorithms are applied respectively in networking field of 5G. In networking, we can apply most of the two algorithms, reinforcement machine learning and unsupervised machine learning. These two have previously been discussed in a little bit detail at the start of the presentation. Now we have three fields in which algorithms can be applied to networking. First of all, base station switching, second routing, and third is clustering. These all three are subsets of networking. In BS switching, first of all we have deep reinforcement learning, Q learning, and K-means clustering. These three can be applied to the base switching as a very intelligent method is required. It's a very sensitive subject with respect to 5G. Second is routing. Routing is also very important as an efficient routing algorithm can preserve the connectivity among the devices. We can apply here Q-learning, CNN, and RNN. These are all types of neural networks. Neural networks is basically in which data is provided and then some sort of function particulars in a specific way to perform specific task. Neural networks are comparatively a very complex topic as compared to other simple algorithms. In clustering, we have simple K-means, deep reinforcement learning, and dense neural networks. These are methods in which these can be simply applied because clustering, we have some already available algorithms such as K-means available on the internet, and one can also modify it according to the use. Now let's see how machine learning algorithms can be applied in the context of mobility of 5G. Speaking of mobility, we can apply reinforcement learning, all three, supervised and unsupervised algorithms in context of mobility. The three most famous that can be applied and which are useful are Q-learning, self-organization map, and reinforcement learning. Reinforcement learning is clear from itself that overall all of the algorithms can be applied to reinforcement learning. But let's see what self-organizing map is. Basically, self-organizing map, also called as SOM, is a type of a neural network. As we discussed before, neural network is a process in which different artificial neurons, such as those like resemble in a human brain, are connected to each other to perform a specific task. For example, we have a task, we can break it down or we can perform it in a parallel manner. This is where neural network comes in. We can have multiple types of neural network as we have discussed before. We have CNN, we have RNN, we have KNN. All of these vary depending upon the functionality, depending upon the use. Reinforcement learning, in a specific way talking, it can be applied 3GP handover. As we discussed before, handover is an important strategy that has to be addressed in the context of 5G so that minimum users are disconnected with the each respective node. Now discussing a little bit about each of the resource management, networking, mobility, let's focus on a particular case study in which we will discuss the intelligent authentication process in machine learning. We will apply certain machine learning algorithms in intelligent authentication. We will see how it is used and how the algorithms can be performed in a better way for intelligent authentication. Intelligent authentication is a method in which access is provided only to the specific user. Not any unwanted party is allowed to access the specific data. Now we We have developed such methods in which machine learning algorithms can be helpful in determining 5G models. These 5G models can be either physical models or they can be either statistical models. Both are very different. Physical models are those which depend upon some physical parameters. We have reflection, refraction, diffraction, scattering. These are some physical phenomena that happen and can interfere 5G signals directly or indirectly. But first and foremost, we have 4G developed. So why do we even need more technologies in 5G? What are the problems in current models that 5G cannot enable? For example, first and foremost, we have low reliability. More and more devices are connecting to the internet. We need a method, we need more models to enable those specific devices to be connected to the internet without affecting the current speed of the internet, or in other words, increasing the speed of the internet. As more devices are also connecting, it is difficult for the existing models to provide any authentication to each and every device. Current models are also prone to spoofs. It can be any type of, for example, IP spoofing, in which unwanted user, in which a third party user devices itself as a trusted user but actually is not a trusted user. This is a big problem in today's communication models. And the last is challenge in determination. We have to determine models in which those models can be applied to the real-time physical world in a very specific result. We have to provide ourselves with such a result that can be applied to the physical model, to the physical real-time world. Let's see where machine learning can actually be applied in intelligent authentication. Although we have a number of applications in which machine learning can be applied, but let us be specific and talk about a very few. Let us first see what we mean by high cost efficiency, high reliability, situational awareness, and continuous protection. These are also all very clear from their names. High cost efficiency, when we require a new model, when we build a new model, we also require it to be cost efficient. We do not want to produce a model that is very high in cost and cannot be applicable to any low end user. By high reliability, we need to provide more and more devices to be connected with each individual existing devices. Situational awareness is also a very complex topic. For example, an event occurred at any particular node, any particular network. Now that node has to be updated along all the adjacent nodes so that they know that this situation occurred. That is why situational awareness is also and foremost important. Continuous protection. More and more devices are increasing. They are also very prone to attacks. More and more attacks are also being increased. That is why we need to devise a method in 5G. We need to create such models which can provide continuous protection to the ongoing increasing number of devices connecting to the internet. But the real question is, how do we actually design the model for intelligent authentication? Now this process can be included, can be used for any device, for any model in 5G in intelligent authentication, but let us just discuss roughly how it is done. We have basically three processes ongoing. We have the first, parameter collection, parameter analysis, and its evaluation. In parameter collection, we collect the required parameter for our model. We collect them in different scenarios, in different situations. We take a number of observations and then we perform an analysis on them. For instance, let's say that we want to devise a specific method for those parameters. Then we apply those models and at the end we perform the evaluation. If the evaluation satisfies our current criteria of a model, then that method, then that model is eventually adopted in the real world. It is physically deployed in the real world. Let's discuss about the parameter collection. In the parameter collection, we can say that for 5G models, we collect multi-dimensional data. What we mean by multi-dimensional data is that we collect the data in different dimensions, in different variations, all depending upon our requirements, all depending upon our applications. But the physical model that we are going to deploy, we need multi-dimensional attributes. Those multi-dimensional attributes can vary from physical layer attributes. They can be WSN, wireless sensor network selection parameters, or they can be mobility patterns. These can be devised as multi-dimensional attributes, but these are not only limited to these three. Multi-dimensional attributes can be a number of things that are required in our model. Similarly, we can see that a statistical model is more understandable, is more reliable in our 5G model. The reason being that although statistical model is a bit more complex than physical model, it provides more reliability, it provides more accuracy of the model that is going to be deployed in the real world. As we know, the different layers are being used in a particular network. If, for example, wireless network or computer networks, different layers are being used. The connection between different layers is a very important strategy that needs to be addressed. That is why we need multi-dimensional attributes. Multi-dimensional attributes, by using it, we can connect layers more closely with each other, ultimately forming a more secure and reliable transport layer, or overall a reliable model in which it can be followed in order to produce the desired result. This leads to a particular, roughly speaking, very model-free attributes, model-free authentication. This is why we can use model-free authentication in order to predict any future model. This is where B5G beyond 5G comes into play. Let's now discuss about the parameter analysis. In parameter analysis, we have collected the parameters as discussed in the previous slide. Now we have to perform the analysis. We have to convert that data into some useful form of data that we can later on interpret, that we can later on use in any particular algorithm. What we mean by parameter analysis is that different machine learning algorithms are applied. They can be anything. They can be support vector machines, they can be supervised, they can be unsupervised. And one option is that by using different algorithms, we can observe, if possible, the multidimensional parameters can be reduced to some extent, because reducing multidimensional parameters can overall decrease the complexity, but we do not need to compromise on the overall model efficiency. That is what we basically observe in parameter analysis. But why do we do even different multiple machine learning algorithms? It is because applying different machine learning algorithms can ultimately lead to different behaviors of the parameters we require. That is why different machine learning algorithms are used. So for example, we have one set of data, we can perform different algorithms on that same set of data to perform how data shifts its behavior from one position to another. And multidimensional parameters can be reduced by using a specific task which we call as a kernel function. Kernel function is something that we can provide any arbitrary function of ourselves into the algorithm, and the algorithm calculates according to it. Thus we can see that applying different models, we can have different behaviors. Depending upon those behaviors, we can reduce the multidimensional parameters, thus producing an overall cost-effective model for 5G. Last step, we have evaluation and adoption of the model. By adopting a more latest model, the spoofing can be automatically redacted, it can be reduced, but it is not totally completely erasable. We can use regression classification in terms and at the end we can also use authenticate models to predict real-time situations or to apply them to deploy them in real-time situations. The parameters in this context can be reset, the models can be adopted, models can be changed depending upon the requirements, and algorithms can also be changed depending upon the application or requirement. This alternatively reduces a continuous and situation aware process, thus achieving all three goals that intelligent authentication can provide in the upcoming 5G networks. Let us discuss the last case, which is machine learning in SDN and 5G. So now this is a very complex topic. Machine learning itself and SDN itself is a very complex topic, but the combination of two is very useful in today's technology. It is very beautiful in such an extent by using machine learning in SDN or here specifically to anomaly detection. But let us first cover some basics about SDN for those who don't know about SDN. Basically, technically speaking, we have to see that what is basically SDN. To understand SDN, we have to focus our attention on the network layer of the TCP/IP model. For those who don't know about the TCP/IP model, it is basically a simple 5-layer model on which computer networks works. It is basically divided into two types, namely forwarding layer, and the other one is control layer, control plane. Now these two layers are very different from each other in such an aspect that forwarding layer is something physical. It is the layer at which a practical, for example, a packet comes to a router and it is shifted to its output, it is shifted to its destination where it tends to go. This all happens in the forwarding layer. Now above the forwarding layer we have the control plane or the control layer. The control layer ultimately controls, it generates the flow table for the forwarding layer. These are very hideous topics, so a quite good understanding about this can help in machine learning algorithms for SDN. So basically SDN is something like a controller. It's a calculator for the forwarding table which is then provided to the router in order for the router to perform the routing of particular packets. In order to understand how machine learning can be applied, we have to dig a bit deep into the SDN, or particular in the data processing layer of the SDN. Now the data processing layer can be divided into many types for the SDN, but we will only consider two basic parts with which we are only concerned. Number one is feature selection and then number two is traffic classification. We can relate these somehow to machine learning algorithms, but first and foremost let us first see what these basically features do. Let's say that we have machine learning algorithms running in some other part of the SDN. Feature selection and traffic classification, they both relate each other, they both are connected with the machine learning algorithms. They exchange data with the machine learning algorithms. But let us first see that what do we mean by even feature selection. By feature selection we determine the properties on which the data is to be separated. For instance, the property could be anything depending upon some value function, depending upon some biases function, some regression model function. This could be anything. Feature selection is just based upon some properties that we require the data to have. Traffic classification is such a process in which the unwanted data is discarded. The data that we do not require is discarded out of the box. We discard it out of the useful data. We separate useful data from unuseful data in such a way that we are only left with the useful data that we require. forest is a type of algorithm in which trees are performed. Data is organized into tree structure. We have the root node, and then we move to the end, which we call as leaf node or end nodes. Now random forest usually separates data from unuseful data. We present a condition on which the data is divided from the unuseful data. First of all, we have random forest, we have hybrid based clustering. In random forest, we separate the useful data from the unuseful data, and the benefit of using random forest is that we do not need to prune trees, we do not need to cut data, but data is automatically fitted depending upon the conditions. This is why we use random forest. Now in hybrid pair clustering, we can divide it into two, namely as k++ and adaptive boosting. These are somehow related to each other and ultimately related to random forest, but there are some differences which have to be noted. In k++, the normal data is separated from the attack data. We have obtained data from random forest. Now we have to classify that particular data into further classes, and the first class that we divided is normal and attack data, which can be achieved using a k++ algorithm. It is also a clustering based algorithm. Now adaptive boosting is somehow related to KNN, or we can say that regression model in which different classes of the data are performed. This is why we are using these two algorithms, random forest and hybrid clustering, in machine learning algorithms for SDN approach in 5G. In this way, we can detect intelligent authentication for SDN in 5G. Now this concludes the presentation. This was the last topic. Thank you all very much, and for listening this presentation. Any queries, do let me know. Thank you very much. Good luck for the next time.